Graphing linear inequalities is the last section in this graphing linear equations and inequalities unit. I want you to graph this first equation on your own, the problem of the day, or the 5-minute check, I also call it. Go ahead and graph this using what we have already learned in this class. So it's in slope-intercept form, which means we're going to go, remember we work backwards. This is the y-intercept, so we go down 1, 2, 3. And the slope is 2 over 1, so we go up 2 over 1, up 2 over 1, up 2 over 1, because we're going up 2 and to the right 1. And we're going to draw the line. Okay? That is one skill that you will need today for this section. The second skill are the following points solutions of y is less than 2x minus 3. Now we have done single variable problems like this, but not two variables. So just remember that this represents your x value and this represents your y value. So if this is our equation, then we plug in -2 for our x value, and we plug in 3 for our y value. So we get 3 is less than 2 times our x value, which is -2 minus 3. Now in this case, remember, you don't move anything left or right, you just simplify. So this stays 3. 2 times -2 is -4, and -4 minus 3 would be -7. So make sure you're following the order of operations. Multiplication first, adding, subtracting second. Is 3 less than -7? No, that's false. That's not true. So it is not a solution. Okay. How about 6, 8? 6 is your x, 8 is your y. Why don't you go ahead and do B, C, and D on your own? Go ahead and push pause, and then come back and check if you did these correctly. So if 6 is our x and 8 is our y, we get 8 is less than 2 times 6 minus 3. So we get 8 is less than 2 times 6 is 12. 12 minus 3 is 9. Is 8 less than 9? Yes. So it is a solution. 0, 0. We get 0 is less than 2 times 0 minus 3. 0 is less than, this gives us 0. Is 0 less than -3? No, not a solution. And 1, -4 is our x and this is our y. -4 is less than 2 times 1 minus 3. -4 is less than, this gives us 2. 2 minus 3 is -1. Is -4 less than -1? Think of the number line. There's 0, -1, -4. -4 is further to the left, so it's less than, so it is a solution. Now basically we're going to combine these two skills, plugging in values to see if it is a solution or not, and graphing using slope-intercept form. We're going to use those two skills today to graph linear inequalities. So this is an equality. We have an equal sign. When we graph these, we just draw a line. There's no shading. And the line represents every single point that is true for this equation. But look at this problem. How do we graph all the solutions to y is less than 2x minus 3? Okay, so this time we want everything less than that borderline. So we have to go through a couple more steps for a linear inequality versus an equality that we did in the 5-minute check. The first step, write it in slope-intercept form. Now this one is already in slope-intercept form. Y is less than 2x minus 3. So we don't have to get this one in slope-intercept form. Graph the boundary line. Now, here's the first thing that's different. When we draw the line, we could get a solid line or we could get a dashed line. Now, what I want you to remember is that when we graphed solid lines, or I'm sorry, less than or equal to or greater than or equal to, that would have been a closed-in circle. Okay? A closed-in circle is like a closed-in line. Use a solid line. Now, if it was greater than or less than, those were open circles. So you have to think about what an open line would look like. That would be a dashed line. So now, instead of an open or a closed circle, you decide if it's an open or a closed line. So would this be an open or a closed line? This would be an open circle, which means a dashed line. So when we go to graph this boundary line, it's the same one as the 5-minute check. We go down to the y-intercept, which is -3. The slope is 2 over 1, so we go up 2 and over 1, up 2 and over 1. But this time, since it's a less than and there's no equal sign underneath, we just want a dashed line like this. Okay? So write it in slope-intercept form, graph the boundary line. That includes deciding if it's going to be a solid line because it has an equal sign, or it's going to be a dashed line because there is no equal sign. Now we need all the points that are solutions to this. So let's go back a step. This will be tough. We want to plot these points. Now -2, 3, -2, +3 is here. And that was not a solution. So I'm going to put an X through it because that one did not work. See how this inequality that we used in step 2 was exactly the same one? So let's see if how these points lay out on this graph. 6, 8 was a solution, and 6, 8 would be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8 up here. This one is a solution, so we'll keep it solid and not put an X through it. 0, 0 was not a solution, so X through it. And 1, -4 was a solution. Now, if we continue to test points, if we were to continue to test a whole bunch of points, what we would find is that all of these points would work. Any point over here. And all of these points would not work. Okay? And so this becomes the side that does not work. This becomes the solution side. All of these points on this side of the boundary line will actually work. Now we really don't want to have to test all of these points. So what we can do is just test a single point. Now usually we use 0, 0. Why would we use 0, 0? Because of course it's the easiest point to plug in. So when I say test a point, we're going to take 0, 0, which is right here. Now we've already done this, but let me just reiterate how we do this. We plug it into the original equation. 0 is less than 2 times 0 minus 3. So we get 0 is less than, this drops out, -3. Decide if that's true or false. 0 is not less than -3, so that's false. And that's why I put an X through it. What we want to do is shade the graph, which is always going to be the true side. So we can plug in one point, find out that this is false, which means everything on the top side of this line is going to be false. We don't want to shade the false side though, we want to shade the true side. So we shade this side of the line. But you don't have to shade it in completely, just so I can tell which side is shaded. Okay? So we put it in slope-intercept form, graph the line and decide if it's solid or dashed, test a point, usually 0, 0, and then shade the true side. So the shaded region represents all the points that work for this inequality, this linear inequality. Now the only time you cannot use 0, 0 is if the line goes directly through 0, 0, and if that happens then you have to choose a different point. So let's keep going and see how we do on the rest of these examples. Graph x is less than -3. What do you notice right away? There's only one variable. What kind of line is this if it has an x? Remember, we can slide a v in top. We're looking for a vertical line. So a vertical line, x is -3. Now this is the x-axis. So -1, -2, -3. We're going to draw a vertical line. It's already in slope-intercept form. Well, and then decide if it's solid or dashed. Now it's not really in slope-intercept form, but if you only have one variable, remember you solve for that variable, which is done. Would this be solid or dashed? Now it might be helpful to think, is this going to be an open circle or a closed circle? So this would be an open circle, which means we're looking for an open line. So a vertical open line, you might have to make that a little darker so that it's easier to see. Okay. Test a point. Does this go through 0, 0? No. So we can test 0, 0. So if I take 0, 0 and plug it in here, I get 0 is less than -3. 0 is less than -3 is false. 0 is not smaller than -3. So this point does not work, which means everything on the right side of this line is all going to be false. This is going to represent our false side. We don't want to shade the false side. We want to shade the true side. So that's how we'll finish that one up. Okay. So the dashed line means it excludes, it excludes, does not include these points along the line. So one of these points would give us exactly -3. So a dashed line means excludes the boundary line. If it's a solid line, then it includes the boundary line. So let's look at number 2. Oops. Y is less than or equal to 4. What kind of line will this be? Flip that y upside down. It's going to give us a horizontal line. Flip that y upside down. So find where y equals 4. 1, 2, 3, 4. And we want a horizontal line. But will it be solid or dashed? This would give us a closed circle. So we want a solid line. Okay. Now, does it go through 0, 0? No. So we're going to plug in 0, 0. And we get 0 is less than or equal to 4. That is true. So that means this point is true, which means this whole side represents the true side from here down on this whole side of the boundary line, which means this is the side that we want to shade. We want to shade the true side every single time. How about number 3? This one needs to be put in slope-intercept form first. So remember that means solving for y. If we want to get y alone, we need to subtract x from both sides. Y is greater than -x plus 3. So when we go to graph it using slope-intercept form, work backwards. 3 is our intercept, 1, 2, 3 on the y-axis. What's our slope? Remember, it's technically going to be -1 over 1 because it was a -x. So we go down 1, forward 1, down 1, forward 1, down 1, forward 1. Okay. Draw the boundary line. Will this be solid or dashed? This would have been an open circle, which means we're looking for an open line. So I just connect a little dash next to each of those dots. And keep on going. Okay, so a dashed line means it excludes the boundary line. And let's go ahead and plug in a number. Now this one does not go through 0, 0. So we plug in 0, 0 and we go back to the original. We'll talk more about this in class, but if you plug into the original, then you can't make a mistake with this. If you, for some reason, forget to flip an inequality sign while you're solving it, it can cause a problem if you plug in here. So plug it back into the original. 0 plus 0 is greater than 3. Is 0 greater than 3? No, that's false. 0 is not greater than 3. So this does not work, which makes the whole bottom side false. So we're going to shade the top side. Okay. The last one, number 4. Why don't you go ahead and try that one on your own? Now I do have to tell you, in order for this to fit on the graph, I believe we need to change this. We're actually going to change this to a 6, if it's not already changed. So go ahead and solve that for slope-intercept form, graph it, and shade it, and see how you did there. So we need to get y alone, so we move 3x over. We get y is greater than or equal to, bring the x down first, -3x plus 6. Graph this line, 1, 2, 3, 4, 5, 6 here. And our slope is -3 over 1. So we go down 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Would this be solid or dashed? This would have been a closed circle. So we're looking for a solid line. And we want to decide where to shade it. This one also does not go through 0, 0. So we can plug in 0, 0. What do we get? Go back to the original. Go back to the original. So we get 3 times 0 plus 0 is greater than or equal to 6. So this is 0 is greater than or equal to 6. 0 is not bigger than 6. So this is false, which makes this whole side to the left false, which means this side is going to be our true side. Now, want a quick review on your quadrants? What are the quadrant numbers here? So bring that to class with you tomorrow. What are the numbers here? Remember they go 1 through 4, so which one's where? Okay? And we'll discuss that in class tomorrow. Now, we can go ahead and fill in on your Cornell note sheet what the steps are for graphing them. These steps are right here. So find your Cornell note sheet. When you're graphing linear inequalities, you can fill in these 4 steps right here on your Cornell note sheet.